Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 10, Section 4, Part 6. And today we are working on enthalpy problems. So just a quick review. When we're solving an enthalpy problem, we write a balanced chemical equation. We look up all the enthalpies of formation. We multiply the enthalpies of formation by the number of moles, by the coefficients in the balanced chemical equation. We write the equation and sub in our numbers. So we were given the problem. If the standard enthalpy of formation of solid glucose, oh, I missed that in there, it's solid, we'll have to change that, is 1,266 kilojoules per mole, what is the change in enthalpy when 1 mole of glucose is consumed during cellular respiration in your body? Okay, so then we came up with the balanced chemical equation, and I changed it to solid. 1 mole of solid glucose reacts with 6 moles of oxygen gas to form 6 moles of carbon dioxide gas and 6 moles of water, liquid water. Then we looked up our enthalpies of formation for all of our elements and compounds. We know that glucose is negative 1,266 kilojoules per mole, and oxygen is 0 because it's a plain element. We know that carbon dioxide is negative 393.5 kilojoules per mole, and water is negative 285.5 kilojoules per mole. So then we're going to please write this equation out, because remember you need to write the equation, then we're going to sub in numbers. So delta H equals sigma, the sum of the number of moles of the enthalpies of formation of the products minus the sum of the number of moles of the enthalpies of formation of the reactants. All right, so then we're going to start subbing in our numbers. Let's do it. Okay, so we're ready to sub in our numbers. We have our delta H equals our sigma, and don't forget it's the products first. So let's start with carbon dioxide. So 6 moles CO2 times, we have our delta H of carbon dioxide, which is negative 393.5 kilojoules per mole, plus, remember it's sigma, so it's the sum of all of that. And I'm going to do my parentheses. So then we're going to do water. So there's 6 moles of water. Double check. Yep, 6 moles of water. Times my enthalpy of formation for water, which is negative 285.5 kilojoules per mole. And then all of that minus the reactants. So it'll be the sum of, let's do glucose. So that is 1 mole glucose. I'm going to write it out because I feel like that might be faster than C6H12O6, but either way. And then it was negative 1,266 kilojoules per mole, plus the sum is 6 moles of oxygen. 6 moles O2 times 0 kilojoules per mole. All right, so our next step is going to be to simplify this. I think I'm going to do some different colors. All right, so our delta H, I'll bring that down, equals, and then we're going to need to grab out our calculators. And I just want you to do each species, each compound on its own before you do it all at once, because there's so many things going on that if you do it one wrong, you'll get the whole thing wrong and you won't be able to see where anything went wrong. So 6 times negative 393.5 is negative 2,361, and then the moles cancel, so I'm left with kilojoules, plus 6 for the height for the water. 6 times negative 285.5 is negative 1,713. Again, the moles cancel, so we're left with kilojoules. And then all of that is minus, oops, I was going to switch colors on you. Let's not do that. The reactants, so it's 1 times negative 1,266 kilojoules per mole, 1,266 kilojoules, moles cancel, plus 0. All right, so then when I bring that down, I have delta H equals, and now I'll put this in my calculator, and don't forget we're subtracting a negative here. So negative 2,361, double check that I wrote that correctly. Yep. Plus negative 1,713 minus negative 1,266, and I get negative 2,808 kilojoules. Okay, now let's take a look at the question. Did we answer the question? If the standard enthalpy of formation of solid glucose is negative 1,266 kilojoules per mole, what is the change in enthalpy when 1 mole of glucose is consumed during cellular respiration in your body? So, did we answer with a change in enthalpy? Yes, we did. Cellular respiration. Now, is that an endothermic or an exothermic reaction? So when we look, we know cellular respiration, our body uses that to get energy, right? Like to make energy. So it's giving off energy, so it's going to be exothermic. So when we look at this, exothermics are negative. Is our answer negative? It is. Very good. So we answered the question and we have a reasonable answer. All right, let's look at our next problem. Please write this down. Calculate the change in enthalpy for the combustion of 1 mole of methane gas to form carbon dioxide and liquid water. The enthalpy of formation for methane is negative 74.87 kilojoules per mole. All right, so I'm going to have you write this down and then go through the steps. The first step is to write a balanced chemical equation. So it's the combustion of methane gas, and since it's a combustion reaction, what does methane have to combine with? And then it tells you your reactants here, and then your products. It also lists your products to form carbon dioxide and liquid water. So take a moment and write your balanced chemical equation. Okay, you should have a balanced chemical equation, and the next step is to look up the enthalpies of formation. So just a reminder, there are 4 enthalpies of formation to look up, and you'll want to write them down. So take a moment to write down the 4 enthalpies of formation of your compounds, and remember to label them with what compound they are. Just kind of like up here. Delta HF of O2, delta HF of CO2. So pause the video and write down your enthalpies of formation. Okay, your next step is going to be to write down the equation. So pause the video for a minute and write down this equation. You should have your equation written down, and then the next step is to substitute in your numbers. So just remember, when you're substituting in your numbers, delta H equals, and you're going to take the sum of each mole of your compounds of your products times the enthalpy of formation of the products, adding them together, And then you're going to subtract the sum of the coefficients of each reactant times its enthalpy of formation. Obviously, you're going to have different numbers than here. This is just kind of how we set it up. So pause the video and take a moment to plug in your numbers. So make sure to write everything out and then to calculate the answer. Okay, you should have an answer, and we will go over that in class. And then let's talk about the next step. Write the thermochemical equation for photosynthesis. So before that sounds super confusing, let's just think about it. Thermochemical is a balanced chemical equation plus the change in enthalpy. So we talked about cellular respiration, and you know that photosynthesis and cellular respiration have opposite products and reactants, and we know that no energy is lost or gained. So take a minute and write down a balanced chemical equation for photosynthesis. Okay, you should have your equation, and then let's think about, we know that in cellular respiration it's exothermic and we get 2,808 kilojoules. So what would be your change in enthalpy for photosynthesis? So take a moment and write that down. All right, we will go over that in class. So one more thing I want you to write down. A use of enthalpy. So chewing gum has xylitol. Lots of chewing gum has xylitol in it, which is C5H10.4. And that reacts with saliva and results in an endothermic chemical reaction. What does that mean if it's an endothermic chemical reaction? So we know an endothermic chemical reaction will absorb more energy than it releases. So if the gum is absorbing energy, where is that energy coming from? It's coming from your mouth. So it cools, it draws in heat, it takes away heat from your mouth, so your mouth feels cool and refreshed. And that's how gum works. Thanks, chemistry. In our next video, we're going to talk about energy profiles of chemical reactions and reading energy diagrams. I will see you then. Bye.